Welcome to another math lesson. This is Mr. Pi. We're going to be talking about inverse relations and functions, part 5. Functions that model real-life situations are frequently expressed as formulas with letters that remind you of the variables they represent. When finding the inverse of a formula, it would be very confusing to interchange the letters. Keep the letters the same and just solve the formula for the other variables. When working with existing formulas, it'll be good to remember this highlighted part. Keep the letters the same, and just solve the formula for the other variables. That'll be illustrated in example 5. The function d is equal to 16 times t squared models the distance d in feet that an object falls in t seconds. Find the inverse function. Use the inverse to estimate the time it takes an object to fall 50 feet. When you see a word problem, if you're like my students, you're going to freak out when you read this. Don't. It's just a word problem. This sentence right here tells you what to do. It's a direction. Find, that's a directive word. Find the inverse function. So the first thing we need to do is take the original function, d is equal to 16t squared, and find the inverse function. To do that, we divide both sides by 16, giving us d divided by 16 is equal to t squared. We will take the square root of both sides. When we take the square root of a fraction, you're permitted to take the square root of the numerator and the denominator separately. Since we don't know what d is, we cannot take the square root of it. And the square root of 16 is 4. On the right-hand side, we're left with t. So ultimately, t is equal to the square root of d over 4. I don't know what I wrote there, but it should be a d, the square root of d divided by 4. Right here, we're told to use the inverse to estimate the time it takes an object to fall 50 feet. So d will be equal to 50 feet. We'll substitute that into the formula that we just found the inverse of. The inverse of that formula would be t is equal to the square root of 50 divided by 4. It doesn't tell us to round, so we could put that into simplest radical form if we wanted to. That would be 2 square roots of 5. If we put that into simplest radical form. Or 5 square roots of 2. I said 2 square roots of 5, but it's 5 square roots of 2 divided by 4. So you can run that in your calculator to get an exact number. 5 times the square root of 2 divided by 4. Give you approximately 1.8 seconds. So 1.8 seconds. It appears to be an irrational number on the calculator, so we'll just round that to 1/10 of a second. If f and f inverse are both functions and f maps a to b, then f inverse must map b to a. Here we have a nice image, the domain of f and the range of f inverse, the range of the function f and the domain of f inverse. You can see that there, they map back and forth to each other. So we can conclude that if f and f inverse are functions, they are called inverse functions. For inverse functions, f inverse of f of x is equal to x, and f of f inverse of x is equal to x. In essence, if you do the composite function of an inverse function on itself, or the function on the inverse function of a particular value, you're going to get that same value out. And that brings up this property, the composition of inverse functions. If f and f inverse are inverse functions, then f inverse composed with f of x is equal to x, and we can reverse that order. F composed of f inverse of x is equal to x. Now that makes things very easy for this next example. Example 6t, for the function f of x is equal to 1/2 x plus 5, find f inverse composed with f of 652, and find f composed with f inverse of negative the square root of 86, or the opposite of the square root of 86. So this is actually very easy, not really no hardcore algebra involved, F inverse composed with F of 652 is going to be equal to 652. Whatever you're taking the function, the composite function of, that's what it's going to give. If we have F composed of F inverse of the opposite of the square root of 86, it should be pretty easy for you. That's equal to the opposite of the square root of 86. Whatever you put in, you're going to get out. And we could actually illustrate that because we are taking the composition of these functions. You could find the inverse of f of x here, and then do the compositions like we did here, and we could show that it's actually equal to x. That would be another topic for another video. This has been Mr. Polarski. Remember, if you're at my blog or if you're on YouTube, take the time to leave a comment if this video has helped you, or even rate this video or blog post.